This is the completion of the lecture of section 9.2, where we're talking about geometric series. So here we see that if my series converges, then the limit of my terms as n goes to infinity is 0. That means for the series to converge, the terms have to get really small as n goes to infinity. And if I look at it from a different direction, I see that if the limit of the terms as n goes to infinity is not equal to 0, then my series diverges. So let's take a look at some examples as to how this is going to work out for us. Here we see we're supposed to determine whether this converges or diverges, and we see that we have a geometric series with a equal to 3 and r equal to 3/8. Well, 3/8 is less than 1. That's my common fraction, so it converges, and it also tells me that the limit of the terms as n goes to infinity is 0. Let's take a look at another example. Let's say we have this series. So I have the sum as n goes from 1 to infinity of 5n. Now, this is not a geometric series, but if I look at this, I see that my terms continually get larger, and instead of worrying about whether it converges at first, I'm going to take a look at the limit of the term expression as n goes to infinity. Well, that goes to infinity, therefore it diverges. What if I had the series, the sum 5, as n goes from 1 to infinity? Well, that would be 5 plus 5 plus 5. Well, what's the limit of 5 as n goes to infinity? Well, that's 5. Well, even though it didn't go to infinity, it didn't equal 0. So this series also diverges. So now let's take a look at some examples of geometric series related to a real-world problem. So let's see if I can squeeze this on here. Oh, I can't get the picture and the problem all together. So let's just read the problem. Let's just run off that example 6. There we go. So it says, a ball is dropped from a height of 6 feet and begins bouncing. The height of each bounce is 3/4 the height of the previous bounce. Find the total vertical distance traveled by the ball. So what's going on here is you're standing at 6 feet, or you're holding a ball 6 feet high, you drop it, and we're trying to add up all these different vertical bounces, okay? And we know that once I let it go at 6 feet, this is going to come back to 3/4 of 6 feet, okay? So we can look at each of the individual bounces. So if I look at so I can create a series for the total vertical distance by looking at the first drop. So I drop it, that's 6, okay? Then it bounces back up. So that'd be 6 plus 6 times 3/4. So I'm right here. Okay, so that's after the first bounce. If I look at after the second bounce, okay, now I've dropped it, it bounced back up, it bounced back up. But this is what I had for D2, wasn't it? But I have to go back up after that bounce. So I have, or no, it goes back down, sorry. It goes down after that bounce. And then after the second bounce, it comes up 3/4 times 6. 6 times 3/4 squared. So now, these two pieces here are the up and down of the first bounce, okay? So that's the total distance after 2 bounces. Let's look at the total distance after 3 bounces. So to make the third bounce, I have to go back down, Okay, so this is the drop. This is from my first bounce right there. That's my first bounce, up and down. This is back up after the second bounce. This is down after the second bounce. This is up after the third bounce. So now let's look and see what we have. So we're ending up with a pattern that looks like this. Well, I can move on and make a generalization so that the total vertical distance is now 6 plus 12 times 3/4 plus 12 times 3/4 squared, and so on. Well, this looks very similar to a geometric series. We have to do a little bit to it to get exactly what we want. So let's do some algebra to get what we need. So here's what we have written in summation form. So I know that I have to have it from 0 to infinity to satisfy a geometric series. I have to have a, and I have to have r raised to the n. Well, I have it to the n plus 1. So what I'm going to do is I'm going to take that extra 3/4 as a factor and set it out by itself with the 12. Okay? So now, if I take out that piece, I have the sum n equals 0 to infinity of 3/4 to the n. Well, I have an a of 1 and an r of 3/4. So because this is a constant, I can just factor that out front. Now I have a geometric series. And because 3/4 is less than 1, it's going to converge, and it's going to converge to 1 over 1, no, a times 1 over 1 minus r. Well, here's my a is 1, and then I have 1 minus r. I have that 12 times 3/4 out front. Well, this all simplifies down to 6 plus 9 times 4, which ends up being 42 feet. And that is how you apply a geometric series.